Hey guys, it's Mr. Knockme here. We're going to be going over lesson 6.3, confidence levels for population proportions. Right? The 6.1 and 6.2 were confidence levels for the mean, and now we're going to go into proportions, which is just another word for percentages. Okay? We denoted proportion with the letter P. Right? We did this back when we were doing binomial experiments. P was the probability of success for a single trial of a binomial experiment. And remember, a binomial experiment was just a success or a failure. It's either you succeed or you fail, heads or tails, yes or no type of question. Right? So when you do the proportion, right, it's still just going to be a percentage. Right? And then for the population proportion, we denote it with P. Okay? Now, to do the point estimate for our population, since we can't always measure for the whole entire population, right, is going to be the sample proportion, right? The proportion of successes in a sample, and that's denoted with this guy right here, and we read that as P hat. P hat. I know it's weird. For the sample mean, we use X bar. I don't know why they switch it to a hat now when they're doing with P. But to calculate the sample proportion is very simple. We just take the number of successes in the sample, we'll just call that X, and divide it by the number in the sample, call that N, or the sample size pretty much. Okay? And that P hat will be our thing that helps us measure, right, or estimate what the proportion is for the population, right? Just like X bar is a good help to measure out what the mu is for the population, right? This can also be done with proportion of failures, and just like when we did binomial experiment, if P was your success, Q would be for your failure, and for the sample size, we're going to use Q hat, right? I know that's a bunch of stuff, but it's not actually that hard to calculate p hat when you're thinking about it. This is really all you're going to be focusing on is this guy right here. Number of successes in a sample divided by the number in the sample. Okay? All right, let me show you. Let's take a look here. In a survey of 1,000 U.S. adults, 662 said that it was acceptable to check personal email while at work. Find the point estimate of the population proportion for the U.S. adults who say it is acceptable to check personal email while at work. So in this case, the success, right, in this case is people who said yes to saying it's acceptable to check their email at work, right? And the number of successes we have here is 662, right? Number of successes in the sample is 662, right? Divided by how many people were asked, how many people are in the sample that we're dealing with, and the number of people that we're dealing with in the sample is 1,000. Okay, so the number of successes is 662 divided by the number that was asked, which is 1,000. That's all you have to do to calculate your p hat. Okay, so p hat would be equal to this, and you just plug that into the calculator and see what you get. 662 divided by 1,000 is going to give us 0.662, and that's what your p hat is. Okay. When you're doing these problems, you should always get a number that is going to be either equal to 1 or less than, right? Less than or equal to 1, right? Your proportion or your percentage should not be more than 100%, okay? And that's what you should keep in mind when you're doing this. It should also never come out negative, okay? So those are two things that will help you figure out if you've done this correctly or not to help you out. There's two problems here I want you to try, okay? Find out the point estimate for number 1 and for number 2. That's going to be it for today, guys. It's going to be a very short video, but I still want you to attempt these two problems and just calculate what the point estimate is for P for these guys, and then submit it onto Canvas for me. Don't submit the notes just yet. We still got a couple ways to go, but please submit the answers to these two problems on there. And I'll see you guys next time, all right?